Hello all, welcome to i-tutor Academy. In today's session we will start with UNIT12 subsection 6 of Mmpc 008, that is data modeling. We have discussed earlier that an organization need to store data to process and have the desired information, and this is done through database. So data model refers to different views of data and the underlying relationship among them. Data modeling is the process of creating a data model for an information system. It gives a visual representation of either a whole information system or part of it, and it shows connection between data points. It illustrates the type of data used and stored within the system, the relationship among these data types, the ways the data can be grouped and organized, and its formats and attributes. This process is used to define and analyze data requirements need to support the business process within the scope of corresponding information system in organizations. So data models are built around business needs, and rules and requirements are defined upfront through feedback from business stakeholders so that they can be incorporated into the design of a new system or adapted in the existing one. The process begins by collecting information about business requirements from stakeholders and end users. Business rules are then translated into data structures to formulate a concrete database design. A data model can be compared to a roadmap and architecture blueprint or any formal diagram that facilitate a deeper understanding of what is being designed. Data modeling techniques and methodologies are used to model data in a standard, consistent, predictable manner in order to manage it as a resource. And data modeling makes it easier for developers, data architects, business analysts, and other stakeholders like program testers, manual writers, IT package selectors, engineers, managers, related organization, and clients to view and understand relationship among the data in a database or data warehouse. Further benefit are that it can reduce errors in software and database development, increase consistency in documentation and system design across the enterprise, improve application and database performance, ease data mapping throughout the organization, improve communication between developers and business intelligence teams, ease and speed the process of database design at the conceptual, logical, and physical levels, help manage data as a resource to be used to integrate information system, be used in design of data warehouse and data repositories. Data model can generally be divided into three categories. The process starts with a conceptual model, progress to a logical model, and conclude with a physical model. The three data models are as below. Conceptual data model, they provide view of what the system will contain, how it will be organized, and which business rules are involved. Conceptual models are usually created as part of the process of gathering initial project requirements. Typically they include entity classes and their characteristics and constraints, the relationship between them, and relevant security and data integrity requirement. So there is sales, then there is depend on time, and product, store. Okay, so these are interconnected ones. So conceptual data modeling. Logical data model is there. They provide greater detail about the concepts and relationship in a domain under consideration. They indicate data attributes such as data types and their corresponding length and show the relationship among entities. Logical data model don't specify any technical system requirement like storage requirements, etc. Time, product, sale, and store is there. So in time there is date, product ID, sales, store is there, and in under the date description, month description, year, week, like that. So logical data modeling is there. So refer figure 12.2. And physical data model, they provide a schema for how the data will be physically stored within a database. As such, they are the least abstract of all, and they offer a finalized design that can be implemented as a relational database, include associative tables that illustrate the relationship among entities, as well as the primary keys and foreign keys that will be used to maintain those relationships. So here is a model of physical data modeling. PIA, physical data modeling. Time is there, product, store, fact, sales are there, how it connected. Okay, so refer this 12.3 figure also from your Ignou study material, and parallelly use your textbook also, and your this content is more clear for you then. Okay, and numerous commercial and open source computer aided software engineering case solutions are widely used today, including multiple data modeling, diagramming, and visualization tools. And some example: Irwin Data Modeler, Enterprise Architect, ER Studio, and free open source and data modeling tools such as Open Model Sphere. And all the above data model can be broadly classified into three. There is record based data model, object oriented data model, dimensional data model. Okay, the record-based data modeling has been in practice since beginning of application software development using database approach. So three sub-models are there: hierarchical, network, and relational model as briefed below. So hierarchical model, these are the early data model used in 1970s. Hierarchical models captured the intuitive hierarchy of the data elements. Network model, since the hierarchical model are unable to represent data item that existing at two different level of hierarchy, network model were proposed, and the notable system built using this model were ADABS, IDMS, Integrated Database Management System, and DBMS-10. They were found to be more powerful and were used in various sectors like telecom, production house, etc. Relational model, though network model were quite powerful, they lacked in elegance and were not simple to use. DBMS with relational model is known as RDBMS, and the system built on this data model were DBase, XBase, and Oracle. Almost all commercial systems presently available like Oracle 11G, Oracle 12C, Oracle 18C, and the latest as shown now in 2021 there is Oracle 19C, that is SQL Server. MySQL are built on the relational models, and data modeling in RDBMS is achieved in two levels. There is ER modeling that builds the entities and provides entity relationship diagram, normalization which remove the redundancies, and object oriented data model came into practice because of object oriented programming, and it became popular in the mid 1990s. The object involved and are abstractions of real world entities, and objects are grouped in class hierarchies and have associated features. Object oriented database can incorporate tables but can also support more complex data relationship. This approach is mostly used in multimedia and hypertext database. The approach is, however, not as simple as the relational data modeling, in which case ER diagram very simply depicts all the entities, attributes, and relationships between entities. Object oriented data modeling has advantage of getting more redundancies removed and hence use less storage space as compared to ER model. Next is dimensional data model. It is designed to optimize data retrieval speeds for analytic purpose in a data warehouse, while OOD and ERD data models emphasize efficient storage. Dimensional model increase redundancy in order to make it easier to locate information for reporting and retrieval. Entity, any real world object that has certain properties, and these objects are uniquely identified by the system on the basis of this. For example, student is an entity. Okay, so attribute is the properties of an entity. Like a student entity can have attributes such as student name, roll number, class, etc. Relationship, specify the meaning relation between the entities. This relation can also have attributes. Okay, so here is one chart is there: degree of relationship, that is the specific occurrence of entity with the other entities. So please refer that. And one to one entity manager manages department. Okay, so one to many is their manager, then supervise, and employees are there. Okay, many to many employees works for, and project is there, so many to many. Normalization is another concept in data modeling. Normalization is a process of converting complex data into simpler form without any loss of information. And next is relationship. This relation has the following problems are there. So library is there, you know so there is here duplicate data exists because member address will be repeated if a member issue more than one book. Like insertion problem and anomalies is there. If a member does not issue a book, then we cannot record the address of a member. And updating problem, if a member has issued 2 or more books, then address is necessary in all, and if a member's address needs to be updated, then all the records needs to be updated. Delete anomalies, here if we delete the issue details, then address would not be there. But all the above problem can be eliminated by normalization if this single relation is broken down into 2 relationships. So there is member, then details are there, member is, and trans are there. But this required a join between these 2 relationships, which is very expensive. So unnormalized data table is there. So there is roll number, name, subject, marks, like that. And table 2 is there, first of normal form, roll number, name. So these are the data. So okay, how it is connected. So data is still redundant in the form, and here combination of 2 keys, roll number, subject is primary key, and but the attribute of this table depend on the part of the PK, and roll number and subject determines marks. Roll number determines name. Name has no dependency on the attribute subject. This may lead to following problems. Insertion, the name of subject cannot be recorded until a student give any exam. So updation is there, deletion is there, like that. Okay. So activity A is here based on this section. Try to do it. And next is attribute in tables. And in ER model, each entity and relations has a corresponding table. For storing the data in a database system, each column in the table have a certain type of data. For example, when we create a table for employees' personal data, then we may have different fields like name, address, phone number, age, etc. In this, if we take the attribute name, then this would be of character type, and age and phone are numeric type. Sometimes an attribute of a table T takes the value from a set D that is known as domain. A domain is defined in the case when we want an attribute to take some exact set of constant. For instance, the domain of the attribute age for a particular post that a candidate can apply for might be defined as consisting of all the integer number between 18 and 25. On the other hand, the domain of the marks column might be defined as all the numbers between 0 and 100 with at most one non-zero digit after the decimal point. And the significance of declaring a column of a table to have a particular type is the ability to compare the value of 2 different columns resides on this declaration. Next is developments in a database technology. DBMS consists of a collection of interrelated data that is called a database, and collection of a program to manage and assess the data. And RDBMS is a collection of tables, each of which is assigned a unique name, and each table consists of a set of fields and store a large set of records. A data warehousing is repository of data collected from multiple sources and stored under a unified scheme that resides at a single site. Okay. So here is advanced databases like object-oriented database. In object-oriented database, each entity is considered as an object. And object relational database, in object relational data model much is the same as the basic relational data model, but for the fact that object relational database also handles complex data type and complex object structures. And a spatial database, these database contain geographical database, clip design database, medical and satellite image database, and time series and temporal database. Text and multimedia database is there, heterogeneous database, and world wide web database. So World Wide Web has a data object linked together to facilitate interactive access. Activity B is based on this section, and the next one is database administrator and the role. What is the role of administrator? Large and complex database need a lot of maintenance to work in a proper manner. So the database administrator, that is DBA, does this maintenance, and DBA is the supervisor of the database and hence have a highest level of expertise. DBA centrally controls the database and administrates the overall user community. DBA also takes care of the data and controls the database structure also. And DBA account is sometimes known as the system account that has the powerful capability that other regular database under users don't have. And sometimes when more than one user uses that same resource such as the data, there may exist the conflict, but the DBA seeks for the compromise and takes care of the conflict for the benefit of the organization. And the database and the data warehousing. Database is collection of data on a subject, and the word data warehousing was first introduced by Bill Ignou in 1990. According to him, a warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management decision-making process. You will read in detail about data warehousing in the next unit. A data warehouse is a central repository for significant piece of the data that are collected by various business systems. Okay, so this is about this unit. Please read all the sections once from your Ignou study materials. Okay, in between any doubts you can contact us. So summary of this unit is here. Data consists of facts and detail about things, activities, transactions, etc. Data can be stored as a resource that can be drawn later on the process in this unit we have discussed about the prominent features of a modern database management system. Understanding DBMS is very significant for a manager dealing with information, and also you learned about modeling data and different data types also. Okay, so unit 12 exercise is here. So total 6 questions are there. It's very important, like your assignment, you just do it. What do you understand by data and information? Give 3 examples each to distinguish between data and information. Second is explain the meaning of the term database, database management system and database administrator in your own words. And explain what do you understand by database management system, describe its component. What are data model? How you would classify the data model, differentiate between various data model with the help of an example. What is normalization and why it is used, and explain with the help of an example how would you derive normal forms. And discuss different type of data in database system and what are the developments in database technology with respect to data type. Okay, so these are the questions from this unit. You just try to do it, and for more MBA videos you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.